Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are continuing with the electromagnetic radiations and we're doing the lenses and the ray diagrams. So lenses are like a small topic because we only have to make like how to make the ray diagrams with the lenses. But except that things, we all know that what are the parts of the mirrors. The mirrors parts are all are like in this two are same. But there are sometimes a different part, like we do the vertex point with the mirror, the center point of the mirror with that vertex. In that case, we call this as a optical center. In that case, we do all the rays passes to the focal point. In that case, we all go to the principal focus. That terms can be different, but the scenario, that all the things, the special case, that all can be the same in this too. So let's do it and that know more about this, and they will tell you that what are those points we are dealing with that which are like different from the other points. So for lenses, light will pass through the lenses and undergo the refraction. With the mirrors, they will do the reflection when they pass through the lens. And this they do the refraction because we're dealing with the refraction topic so far. The reason we are zooming the thin lenses is that in reality, the light would reflect twice with the lens, once when it enters and one when it leaves. So which creates a lateral shift. So this is called the lateral shift. That once that is an actual line and other is that lateral shift. Because of the entry and exit, they will do the twice lenses can be passed with this. They will do a refraction twice. So just have to know that doing like any question from there. You assume that the lens is the thin enough that the reflection is only occur once, not twice. You will think that there's only once, but not we dealing with the lateral point anymore. We just have to know this the lateral shift in that lenses. We just know about they occur only once. So that's all we do. So there are two types of lenses. As we have a two types of mirrors, we have a two types of lenses too. So the first type we have a converging lens. The converging lens is more likely the concave mirror. Converging lens reflected rays traveling parallel to a principal axis inward and to intersect at the principal focus. In that thing, the missile goes and they go focus at the same distance, at the same part of the mirror. But in that case, like they go to principal axis, the center point remains the principal axis in that, and they go to the reflection and they do like this. The arrows you can see, they pass through principal focus. In that case, we deal with the principal focus, the intersect at the principal focus. In the convergent lens, convergent lens is also known as the convergent mirror we call as the concave mirror, and this behave like a concave mirror, like same type of concave, and they all make any virtual image. There's only one special case in this, but this convergent lens can be known as the convex lens. So this name you have to know, and the divergent lens known as the concave lens. Sometimes the question that talking about the concave, convex, they're talking about the converging, diverging. So it can be like very like when you combine that all mirrors and lenses, they will like some difficulty can be occurring when you're dealing with those questions in the mathematical analysis. Diverging lenses reflect the rays traveling parallel principal axis outward to appear as through the origin from a virtual principal focus. As I told you, that divergent lenses concave lens, but they behave like a convex mirror, which is the virtual image is occurring. So you can see what they do like this, and they do the reflection over there, and there is tangent lines those two principal focus to make the image which is virtual. So dotted line will tell you about the virtual image, and we have one special case in convex lens or the converging lens too when we're dealing with the virtual image. So there's like in the mirrors we are doing some three rays. In that too we have three rays which are like similar between the both. So with convergent lens and the divergent lenses, so incident rays parallel to the principal axis and reflected to the real opposite side of the lens focal point, or you can say the principal focus. So you can see that line goes over there and they touch at the focal. They goes over there and they. So that's the first ray you have to know about convergent lens. Second is the reverse of this. The incident ray passes through a virtual focal point and reflects it parallel to the principal axis. So this will go like passes principal focus or focal point, and they do parallel to the principal axis. This with the mirror. Incident ray passes through optical center of the lens, does not reflect it. They go straight like this. They didn't go back like a center of curvature. They go over there and they get back and they does not reflect it. They just pass to make like two lines connected to each other to make the image. So that's the help for this. Ray 3 is very useful in that topic. Divergent lens, incident ray is parallel to the principal axis and refers such that it appears to originate from the virtual same set of a lens and focal point. So the parallel to the principal axis, they are reflected, and their reflected ray made the dotted line to the principal focus or the focal point and made the image, which is virtual. The dotted line made the virtual images always. Incident is aimed towards the real focal point. When it passes the lens, it reflects parallel with the principal axis. So this goes over there and they do reflected straight line. And that line goes further to touch with that focal point. So they reflected with the parallel with the principal axis and they will make that point over there, the standard point. Or they can also stand it towards this. Because this is a refractive point, they do infinity. If we like incident ray can be extension of incident ray, they catch at that focal principal focus. Incident ray passes through the optical center of the lens and does not reflect it. This is the same as the we do with the convergent lens. They do straight and they do back. This is both ray 3 are the same for convergent and divergent. These two rays are different and we have to know about these rays too. We use that rays too. So you can see over there we have all the rays in one image. You can see this is optical center, this is object, and this is the image. So you can see how the image can be made. We have to make the three maximum of the three rays we have to make the thing look nice. So I do object over there, and you can see their virtual image over there. The virtual image you can see over there. So that's the thing you have to do with the convergent and divergent. So this is the ray diagrams. So let's deal with the ray diagrams, and also I didn't like go through with the all the characteristics of this. So in this too we have to find the magnification, attitude, and the type of the image. So that's all thing I have to do in the same this too. So let's move on to the thing, and we have the mirror, and this is the divergent lens. We have a divergent lens, and that means we got the virtual image always. We got the attitude of something and magnification of the upright. Let's make that image now. So let's take this straight. Okay, we have the object over there. So you can see object over there, and you have to make the line from here. So firstly, I will do the parallel to principal axis and that reflected. So that do that thing first. So this goes like this, and they move like this. The first thing I made this. The second line I made that which will like if I stand at that point, you can see they touch at the principal focus, which is a focal point, and I have to cut this dotted line, not this line. I have to touch this line. So to cut this line, I made the line which goes straight to the optical center and does not reflect it, which will cut this point. So from the object, I will make that line. So make sure they will pass through optical center. This is the center of the lens, and there you can make this. So right over there. So you can see that this is the another line of this, and this goes straight to this, and they didn't reflect it. So this means that line which they mentioned, that which the point they are cutting to each other, this is your image. You can see you get this such a small image, which means your magnification is diminished. Your attitude of this is upright. You see the upright image, this is up, but the right hand side of the image, so this is upright, and the type you get is always in the divergent lens is virtual. So that's three things of characteristics. That's the image you have to make in this. Let's move on to for the convergent lens. So I have to do the same thing. Now your object is over there. This is like beyond 2f, which is we can say that beyond the center of curvature or beyond the principal focus. So it's beyond everything. So that's the thing you have to know. So I have to cut the two lines which are both reflected and made the line. So this is not like a virtual type, and you have to make the which first I made the line which is parallel passing a focal point with another side. So made that line over there and passing through this point right over there like this. Made the arrows for your convenience, and now I made the another point which is go straight to this, like the optical center, and might be they touch with that point at some point, which will make my life easier for this. And make sure they cut exactly to this like this. So put that point like this. You can see this is my arrows. You can see over there they touched some point, which is now inverted image. So you can see. So for this, your magnification is again diminished. This is smaller than object. So diminished. Attitude of this is inverted, and type you get is the real image. So that's the thing. This for convergent lens. It's easy. Okay. So this is two examples for convergent and divergent. Now we move on to a special case, which is very important. Again, with the mirror, we do the special case, which is very important. And this case is very important again. They will give like the scale type of image. So they mention that the object is shown to right of the lens with a focal point of 5.0 centimeters. Determine the location of the image and the characteristics of the listed. If they are like right of the lens, between the lens and the principal focus, so you get the virtual image in that case, which is a special case. So let's make this. Firstly, this is object, and I made the image, which is parallel to the principal axis, and then passing through the principal focus. So this is right over there. Pass through this, and another point I will make that which is straight to the pass through straight to optical center and does not reflect it, the last ray number third. So this will like to those over like this. You can see this will doesn't touch anymore. They will go straight and straight to the infinity, and they didn't like touch anymore. For this, we extended both the reflected rays and get to know about where they match virtually. So this ray 1 and this ray 2, you will see that right over there they will touch both, and from here you will get your image. You will get your image over there, which is very enlarged. So magnification for this is enlarged. Attitude for this is upright, but right of the object, and the type, this is a convergent lens, and you get a type of virtual image. This is a special case. So that's how you have to make the, like this is the same kind of thing you did the mirrors, but there's something different rays you have to follow. The three rays are different and the lenses are different. Just do the same thing. We have one special case in that, one special case in this. Mathematical analysis is the all the same thing you have to do in the mathematical analysis. So that's the thing you have to do, and you will get the summary of this, summarize all the things, that where you get the objects. You don't like, you don't have the anything in the written, you can like make the get this lens, that this thing, but you have to know this for the mathematical analysis. For the divergent, you get the this thing, that always virtue appear and diminish. This is special case. So that's all for this lesson. So in the next lesson, we do some mathematical analysis of this, and we will come to end of the refreshing part, and then we start with defreshing. So that's all for this lesson. Learning by self EduVibe, learn small, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay creative with EduVibe.